Well, welcome everybody to today's webinar titled Predictive Analytics, Quantitative Modeling and Scoring Made Easy. This will be about a 30-minute webinar, and then we'll follow it with a Q&A discussion. I'm Doug Cogswell. I'm the host. I have 15 years of experience in the BI sector, and then before that, quite a bit of experience doing varying kinds of data analysis and helping businesses with strategy and decisions based on analyzing the data and information. We're going to be joined today in a few minutes by Dana Lisa Radu, who's the Manager of Business Analytics, Reporting and Training at Michigan State University. We're actually going to replay a session we did together at our user conference a month or so ago. In terms of logistics, if you have questions during the webinar, there's a chat panel at the lower right corner of GoToMeeting. If you type in there, we'll pick it up and we'll be answering questions at the end. If we don't get to all the questions today, we'll follow up individually with you. Also, you can raise your hand. There's a facility to raise your hand, and we can unmute you, and you can come in live at the end of the webinar. And we will be making the webinar and the slides available after the webinar finishes. It'll take us about a week to get that up and out to everybody. So the first thing I want to do is, before we get to the discussion with Dana Lisa, which is about really how to use it, I want to actually go through an example and build a model to show you what this is all about. Because what we're trying to do here is take data and help people explore it visually, but also to then use quantitative modeling techniques to make it easy to understand. So I'm going to quickly bring up an example of an advisor project. So this is for grade and course analysis in a university. Our project is typically a set of pages. The first page is on grade spread, and we'll look at some of the other pages as we go through. We're looking at 2 semesters, a fall and a spring semester. There's 3,300 students in this school roughly, and there have been roughly 20,000 grades. The distribution by department, the weighted average, you can see there's quite a range. So a question might be, who are getting the D's and F's? And I'm worried about that because people who come in and get D's and F's are more likely to leave and not complete, and that's the thing we don't want. So this chart is literally just tallying grades. There's been 7,000 A's in this 2-semester period. There have been 1,000 D's and 1,300 F's. So let's assume the D's and the F's are the problem. I can select them by grabbing them with the mouse. So that grabbed 2,431 course grades, which impacted 1,126 out of my 3,200 students. That's a big percentage of my students. I can visually explore it because I'm seeing the selection colored, and the hotter colors, the redder colors are the worse grades, the green colors are the better grades is the color scheme. I can sort of see that by semester they're about equal. You see the coloring is about the same percentage. I can go to the courses and profs page, which here I've got all the courses, all the professors. So at the top are the ones with the more D's and F's. Composition 1 has 147 D's and F's out of 622 grades. That's 24%. Down in the bottom in here, in the middle part, if I take like one of these courses, let's pick this big one, biochemistry, 2 out of 6%. So I've got some skew by what course it is. I've got some problem instructors up here who are giving out a lot of D's and F's. For instance, Brian Parkingon gave 62 D's and F's, 18% of his 346 grades. I can see over here the lower level has more color, so it's a little more skewed. The graduate level is less. I can go to the page in student bio and geography, and hey, there's some skew by age over here. By high school, I've got some problem high schools like Southland Academy. I've got 133 students in, 57 of them, or 43% of the students coming from that high school got a D and an F. I can see I'm a little more skewed towards male than female. So part of visual discovery is you can select the target population, like the people who got D's and F's, and work through the visual charts, which are arranged by the selection to see where there's higher skews. But there's a lot of factors in here, so let's now use some predictive modeling, some regression-based analytics to get a better feel. So go to the task view. There's a set of things you can do with an advisor project. I'm going to build a predictive model. Opens up a panel. I'm going to create a new model. I'm actually going to go back to my page over here. Just go back to the page so I can show you what I'm doing. Build a new model. I'm going to call it bad grades. I've got several tables in here. I'm going to model the grades table where there's information on the courses and the students. I can do a typical regression-based forecast or a classification model. I'm going to do that. That's going to try to figure out what's up with people who got the D's and F's, the target versus the base population, which is everything else. Now, I selected final grade, so I need to take that off as an explanatory factor, or the model will tell me that explains 100%, which is not what I want. I click OK. So this is now running 30 to 40 models behind the scenes. It's going to pick the one that best fits this data and come out in a few seconds with some results. So the model runs, and it's going to complete, and we'll see from an information perspective, are there enough descriptive characteristics to describe the target? Yes. Are there enough rows so that the model is predictive? Yes. What's the biggest factor? The number grade explains 50% of this population, and it looks like lower. Well, wait a minute. That's the same thing as the letter grade, so I actually should have excluded that as an explanatory factor. So let's edit the model, take the number grade out, rerun the model. So now I'm editing the model on the fly, and these are really rich regression algorithms that we've packaged in a way that business people and analysts can readily use. You just need to have some sense of the data, causal factors. It's all point and click. So now my information is a little less descriptive because this isn't bad, but it's less. The instructor, 22% of the explanation of the D's and F's is the instructor, and some instructors like Ray Vanilla give a lot of D's and F's. Others like, go down here, Liji Bagoom, are not inclined to give D's and F's. The second thing is the course title. I've got problems with like college algebra composition, but some of these I don't get D's and F's, like beginning ballet and beginning tennis or design concept. So there's a skew here by instructor and course. High school GPA plays a factor. Lower GPAs coming in, more likely. High school. I've got some high schools like Avondale High that are more likely, highly more likely to produce a D and F. Some schools like Homeschool Abika or Allen C. Pope High School are not likely. So those students are going to do better. So I've actually seen some of the things I found visually did come up in these modeling, but the model gives me a much richer set. It's also predictive. So now what I want to do is score the whole population to find who else might have a risk of getting a D and F so I can take corrective action. So I click Predict. Now it's running the model against this whole population of everybody, and it put new fields in the table called Selection Predicted and Selection Score. So let's look at what the model said. I pre-created a model output page. So, I've got my target population of 1126 students. A couple of charts to see the model output would be a bar chart and a histogram. So let's bring those up and move them over, put them on some data, rearrange the page a little bit. So let's put the bar chart on the predicted score, which is a 1-0 bin. Put it on the grades table. Here's the scores that were added, the predicted. Click OK. Whoops, I put it in the wrong field. I meant to put it on the predicted. That was the range, not the number. So user error. And then I'm going to put the histogram on the score, which is the range. So now I can see what's happened here. The model predicted that 2,396 of my grade participations would be D's and F's. 937 have already had the problem. It predicted these would not have the problem, and there's some false positives because the coloring at the bottom, there are some people who had problems who weren't predicted to have a problem. But this is pretty good model. And this is the range of the scores. They range from low to high, and the model is taking this right side and binning it into a 1 and a 0. So if I actually want to get the problem students, I can exclude the selected, which is my target, which leaves me everybody else. So here are the ones that are predicted to have the problem, and they're colored cool because they haven't had a D and an F. Select them and get rid of everybody else. I've dropped down to the 734 students in these courses that are expected to have a problem. Now, I might want to go further. My list here is updated for the 734, but I'm really do this at departmental level as the discussion goes on. So I'm going to go up here, add another chart, put it on this table. The people, the students, I'm going to do by major. Put it on the field major, flip it over here. So now I want to say maybe I'm working with the biology department. So these are all the student majors. Here's the biology department. There are 33 students in the biology department who are at risk. I can click the bar here. So now I've got, out of the 734 total at-risk students, I've got the 34 in the biology department. I can right-click on this chart, export the data, put it on my desktop. Now I've got the data out of here in Excel, where I can sit down with my biology dean or department chair and go over this group. That's a quick run through of how we can pretty quickly, in 5 or 8 minutes, build a model, look at the data, understand it, and come to some conclusions. So now let's turn this over to Dana Lisa and go into the Michigan State experience. So now let me introduce Dana Lisa Radu, who is the Manager of Business Analytics and Reporting from Michigan State, and she's going to talk about the work she's done there. Hey, Dana Lisa.
Hi there.
I know you've had a couple of experiences with Advisor, so appreciate your expertise in taking the time to talk to us today.
Sure. Thanks for the opportunity to present. And again, I'm really sorry I couldn't be there in person today. A quick bit about myself. I'm the Manager of Business Analytics, Reporting, and Training at Michigan State University Advancement. I've been in the field for over 14 years, and prior to MSU, I was at the University of Pennsylvania. In both schools, my team supported up to 28 schools and centers for data analysis, reporting, and modeling. And in both places, we relied on Advisor pretty heavily for different projects, whether it was a dashboard or just data visualization, and definitely the modeling. I wanted to talk a little today about project preparation for modeling. I guess it's an overview or a little introduction. And this is the outline for this slide. To go over some goals, data collection, data preparation, and ways to test the model and revise the model. So project goals, you want to know what you want to ask. You need some idea of what you're looking for. It should be driven by a question. You can make behavioral models or engagement and donor models that can attempt to predict who your next big donor is, who could increase their reunion gift, or who would likely engage as a board volunteer. The next thing you want to do is you always want to estimate a project timeline. Data collection. Once you've had the question established, you'll know who your target demographic is, whether it's donors or lapsed donors, alumni, domestic clients, etc. And that will tell you what characteristics define them and what fields you need to analyze this set. Are you going to be evaluating RFM, which is recency, frequency, monetary value, or churn rate, which is like attrition, and that maps movement into and out of your collective? This is the data you can get internally from different sources. Most of us have a database or side databases, shadow databases that data is stored at. But you can also think about survey analysis, conducting focus group and peer screenings. So these are all internal, and this is what you can roll into your Advisor project. But then also external data for your perch. This is downloadable, and this is good to augment your data set. And this is anything from, for those of us in advancement, Hoover's data, LexisNexis, market research data, Forbes, Dun & Bradstreet, Melissa data, Zillow, Wealth Engine, any kind of wealth screenings. But there's also fantastic free downloadable data that's available. You just have to be able to download it in various formats, and that could be SEC data, SOC data, and FEC data, for example, for political giving.
Yeah, so Dana, Lisa, just on this, I know we talk about, when we do our workshops, the idea of a target, which is like your question, what is the question, who is the target, what are we trying to look at? And then this is sort of then, what's the available population or the base population you want to compare to? And then
Right.
this is what we often say too, is you need to think through hypotheses. What is all the potential factors that could cause a target to be different than everybody else, the explanatory fields? And you make a great point. Sometimes this is going to be in the advancement tables that may already be loaded in an Advisor project. Sometimes it's coming from something else, and the model will be much better if there are other characteristics, other facts you can get your hands on and bring in. It could be, as you said, outside peer screenings. It could be click-through data from a newsletter. It could be surveys. This is, I think, a key point here. The model is going to be as rich as the set of data you can bring to it, and that requires this upfront sort of thinking, hypothesizing before you jump in and start doing things.
And Doug, that's an excellent point. Most of the work for the best models, in my experience, has been the upfront investment in resources and time and planning. So I don't know what the breakdown would be, 95 to 5% or 90-10, but the bottom line is that back-end work. The planning is where all the preparation has, but the more effort you put into that, the better your model is. And it's true. And the nice thing with Advisor, and I think we're going to show that later in the data workshop, where you can marry different data sets and link them and then create expression builders. So it's all able to happen in this one place. But it's true, the more you bring in, the better it will be.
Yeah, we just I have to laugh a little bit. We had we do like a one-day modeling workshop, and I was in one of these a few months ago, and we usually start like 8:30 and 9 in the morning, and we try to finish by 4:30. It's like 2:30 in the afternoon. We had yet to touch the software. we were well to run the model. We were doing some fields and other tables, linking things back. We were on whiteboards, and they go, "When are we going to use the model?" So that actually happens really quick. It's all this structuring up front. And in cross-table copies calculations, that's the key to getting the right model. And so it's that kind of, people were laughing. It's like, we got to do this sooner. It's like, no, you want to hold this back. And that's like 80% of the time or 90% of the time was prep for then actually running the model, which happens pretty quick.
And that is so true. And here's where we get into the nuts and bolts. So the data preparation, scrubbing and normalizing. So basically, this is the data transformation. This is where it all happens. Let's talk about data quality for a moment. I have yet to see a perfect data set. I don't even know if one exists. And this is why we have to do the best to condition what we've got. As far as bad data, the question is, should you delete it from the analysis? For example, if we have graduation dates from 1800, I don't know how reliable they would be. Missing and null values, birthdays, for example. Birthdays are a key modeling indicator, but what if you don't have many birthdays in your system? Is there another way to estimate this? And perhaps you want to think about years since first undergraduate degree plus 21, or years since first grad degree plus 24. There are ways to account for things that are missing in creative but reliable ways. And you want to keep something else in mind. There might be a highly proven indicator, but a good rule of thumb with analysis is this. If less than 10% of your total data set has the data point, it's almost negated. So you want to maximize what you can work with in the preparation phase, whether it's data collection, scrubbing the data, cleaning it. And as far as anomalies, the question is, should you remove them? Sometimes an anomaly is incorrect most of the time, or sometimes it's actually true and informative value.
What would be an example of an anomaly?
Okay. An example of an anomaly would be if we're looking at a pool of donors for a donor model, and a typical trait might be it took your donors perhaps 10 gifts to make it to their $10,000 threshold. And this threshold would be different to every institution. But an anomaly would be someone whose first gift was $1 million. So that would skew the analysis, but it's a fact, and you want to include it. So the question is, with something like that, you have to find a way to include that in the analysis without skewing the results, and we're going to talk about that when we get into normalizing.
So the thing about normalizing data, with the algorithms that we've used in the product, it does most of the work for you. For example, in most modeling tools like an SPSS, you'd have to do a lot of work on binning data to create groups out of it. Well, the KXE algorithms that we use do that automatically under the covers, and you saw some of that up front in the short demo I did. Also, whether it's categorical or continuous, it handles that. It adjusts, and you really don't have to do anything at all. Null values, it just deals with them. Normalizing outliers, the same thing. The thing here is it can be a real range of numbers, and so if there's something real far out, like you have a $100 million donor, the next donor is $25 million, and most of the population is down well under $1 million, that's a skewed distribution. Well, the data conditioning part of the KXE algorithms handles that automatically for you. The thing that probably requires a little bit more is dates.
Dates are interesting. Dates are more meaningful when they're evaluated as a distance. And what I mean by that is you need a way to compare dates. Everyone might have their first giving date, but comparing that one across the other is meaningless. However, dates are a strong factor in analysis, so you need to find a way to compare apples to apples. So since everyone has a first gift date, see if you can map that against time somehow. For example, you might calculate years between graduation and first gift, or years between graduation and first event they attended post-graduation. This will allow you to profile your target population and then map that back against the behaviors of the rest of your data set. So in other words, what were the behavior patterns of your $1 million donors, and who else mirrors those behaviors?
Hey, Dana, Lisa, that's a great
Sure.
point, and we've actually seen people like put the date in the model, and there's, if you go back of 10 years of data, there's like 3,000 days in there roughly, or something. Which is,
right.
You know, whether it's April 15th or March 31st doesn't really, it's not predictive, it's not causal. But your point, if you subtract it from like the degree year to figure out how long they've been out, or you do something like that, which our expression builder and date parser can easily do, now you've got something that's actually a meaningful potential causal factor versus just a lot of numbers that really have no meaning to them.
Exactly, and this is where Doug and I were both saying most of the work is done. It's time-consuming, and it can be frustrating, but the more work you put on the back end in this planning, the better your model's going to be. And for example, this is not an exaggeration, I've done models where we pull down 300 to 400 raw fields of data, and then after we start the expression builder calculating for something meaningful, that number could double. And it doesn't mean that they're all in the model, but the more you have to work with, the more you can refine and find the meaningful attributes, and these dates are very strong. And once you start playing with the dates and seeing what you can map against, it's truly going to, it'll get exponential how many more factors you have, but these can all be in different models, and it's very helpful. And this can be done in Excel, in Access, if you prep your data elsewhere, which we've done models where we do both, or very easily in Advisor. And I think, Doug, is this the time we could show everyone the expression builder?
Yeah. I'm going to just drop out of the PowerPoint. Here's a prospect identification project. You actually asked over here on the task view. I know some of you are familiar with this, but if you go into here, analyze data, work with data, there's something called build expressions. And this has a whole range. If I take like the entity table here, I can do all kinds of arithmetic, logical, string conversion. So I can do a lot to condition the data in here.
I think that's helpful for people to see. So in other words, if they don't prep their data in an Access database and link it in, they can import raw data. And this is where you can just create hundreds of formulas, and not to scare people, but it can be that large.
Yeah, and I think that's a key point. So this gets you out of having to have something done in the database. So you leave the data in the database as it is, but it's pretty quick to do this in Advisor, offline from the database, and it's a much faster thing that the person actually building the model can do, which saves a lot of time and lets you sort of, as we would say, muck around and try things in a much more flexible way. I would say one of the other things we often find, too, as you're doing these calculations is, for example, activities or events or reunion participation are often in not the core table. They're in an activities or a committees table, but they can be highly causal because they're a measure of engagement, opt-in engagement. I mean, how many times has this person chosen to come to something, and what is that? So that's another case where we can use the expression builder to create a flag in that derivative table, the events or the reunions, and then copy it back to the core table. Then it can be, become part of the model.
All right, testing the model and revising. Model building, as most people know, is an iterative process. You want to build strong models, and you want to check the accuracy of the models, but the best thing to do is test them and see what the model is. I think, Doug, if we could show the model indices right now so people know what we're referring to.
Yeah, let's go back to the project and open the modeling panel on the left. So we built a model here.
And wasn't this the one you built on the fly, and you have 98 and 98?
Yeah, we built it prepping to talk here, so we have something to show. But yeah, it's a pretty good model.
All right, so that's what we're talking about. And I tell everyone we work with, there's no such thing as a perfect model. So strive for your 98s and your 99s, and that's actually good. Doug did this on the fly, and I watched him do it, so I was impressed.
Yeah, we're going to do more on this in a little bit when KXEN talks about the specifics underneath this. But this is basically, do I have enough columns in my data to be predictive? And, if it's in the green, the answer is yes. And this means the model is explaining 98% of the targets. That's good. And this is, does it have enough rows? Are there enough things that the model was built on to be predictive? And, the green is, yeah, there's enough $151 million donors compared against the 93,000 base is enough to be predictive. So this is good. If these come into the red, you've either got to add more content or you've got to add more elements to make the model fully effective.
Thanks for explaining that. That's better than I could have done that. I'm going to record you when I explain it to my colleagues.
Wonderful.
And then we want to go back and test the accuracy and see what worked. And you basically want to do a 2-column, 2-row crosstab of your actual values against your predicted. And what this is going to tell you is how right were you? How many were your true positives? They predicted yes, and they actually gave or did whatever you were predicting. How many were true negatives? They predicted no, and they did not. And then also your false negatives and your false positives. Now, this doesn't happen immediately because if you model something and you're looking for your quarterly solicitation, you have to wait for your gifts to come back in. So this is done over time, but when you keep the model, you can just go back and revise it and see what worked. And then hopefully over time also, as we're all improving our data sets, be able to pull more and more data in and then, create those fantastic calculations.
Hey, Nat, just drop back over here. Yeah, so the cool thing in Advisor is those false positives and negatives are pretty easy to see. And here's a page after we built and scored, and you can sort of see here's a list of people. The model creating the scoring indice that runs from high 118 to the lower. This is going to be kind of low. So this is a ranked ordering of everybody with their potential to be $1 million donor. They're grouped into buckets of 1 and 0. So the model is creating a point along the way of this score and saying these are the ones most likely to be $1 million donor. And it says there's 355 predicted $1 million donors, and then there's 92,000 not. Actually, let me go back over here and select the actual $1 million donors. So these are the ones that are there. So the model is not a perfect, but it's of the 355. 77 are already there, so obviously the group we would want would be to subtract the selection and get the reverse. Mm-hmm. But also, here's an example of kind of the false negative. There's 93,000 expected not to be $1 million donors, but 74 actually are already $1 million donors. So, but that's actually a really good percentage. It's the 74. You can see the statistic is 0.08% of the 93,000.
Right, and you know what else is? Oh no, go ahead.
And over here, the 77 is 22% of the 355, so the model is highly predictive, but there are, over here, false negatives, which would be these 74. Yeah, thanks. I guess one last question
Sure.
is in terms of expertise. You've got a fair amount of, analytic expertise in this area. Advisor, where we try to make this easy to use, I know a question that keeps coming up is, can a researcher or someone who does not have a statistics degree actually use this and make this effective in their day-to-day work?
That actually it's the best tool I've seen. For myself, I don't have a statistics background. I've learned it hands-on, baptism by fire years ago, and with experience. But the thing is, with the other tools out there, you can purchase other software, but the best thing about Advisor is it does it for you. You don't need the statistics. Even if someone were to buy SPSS or whatnot, the other tools, you need a better understanding, and it's hands-on. And the nice thing, and I've told Doug this story before, when I first got Advisor, I actually checked the results of the model, and I did it separately in Excel, and it matched perfectly. So it's silly to say, but maybe worth saying. It's a great tool, and it's reliable. We've had it give us good results so we can go back and say it actually predicted and it worked. And it's very easy for folks. My team, they hadn't used it before, and some of them were new to modeling. And when I was prepping them for our projects, not only on how time-consuming the data prep is, but how friendly the tool is, they were happy about it. And we've bought more licenses now for some of our prospect development staff, so people outside of systems are going to use it. So it's very friendly and it's very easy to use.
And how about the other thing that comes up is, our team doesn't have the skills, so let's farm this out to, outside consultants or experts at doing this. What's your, you've chosen to do stuff inside.
Yeah, certainly I would never, that's not something I would recommend because I've done this, and actually having done it the route I took of learning hands-on, my theory is anybody could learn to do it. And another thing I believe is no one knows your data better than the folks inside. So yes, you could hire consultants to do this, but there's always going to be a gap of understanding, and this isn't something people can't pick up and learn. And if this you might show this with the other presentations that are coming, but if you've got it, let's say for example, a predictive model built on that, the side tab, it's so easy to edit that model. It's just a click and rerun. People love it. I think more people should give it a shot. Should give it a shot and not assume it's too complicated to learn.
Yeah, and that's actually our point in actually creating the software like this, was to make it easy to do the modeling, because the key issues in having an effective model are more understanding the thought process behind the causal factors than actually running the model. And I remember we were in one of these sessions, and you got the factors in, and the model comes out and says that a self-expressed interest in philanthropy and financial aid is one of the key factors to large donations to financial aid, which makes sense, except the person in the room said, wait, that's not right, because I know that the input to that survey question was adjusted based on the people who gave the financial aid. We kind of updated because we knew those people are interested, but that's no longer a causal factor. That's it's related directly to giving the financial aid, and there's no way an outside group would have known that, but the inside team kind of can have that discussion, and that's the key to these models working, is those kinds of discussions and understanding. That's why when we do a workshop, it might be 80% and 90% of the way through the day before we actually run the model, because we're doing all the discussion to set up the factors and those kinds of things.
It's true. We had a model built years back, maybe eight years ago, and we relied on survey response. And one of the indicators in our model was, did you even respond? Did you receive? And did you even respond to the survey? And then we got into their responses. And then after the model was built, we were told that the survey was only sent to our highest donors. So everything was skewed. But that's the kind of thing that if you sent data away or there was no one to explain it, it's going to skew your model and your results. And then you're going to go back and check your metrics and wonder why it didn't work. So if we're talking about this, people should think about the cost of even one license versus the cost it's going to take in resource, money, and time to send your data away. And experience has taught me this. You're going to get the data back having spent the money. The analysis will not be right. Any good shop should want to verify what the results are. So you spent a lot more time. I don't think anybody should have that be their first inclination. I think people should be more assertive and aggressive in wanting to do this in-house. And the nice thing is, you've sunk no cost. You have the software, but you can change this model until you get it right. Whereas if you go with an outside consultant, your data goes, you get it back, it's done. There should be no fear in. I just think people should want to play with their own data. You're gonna get better results. I have no doubt about that.
Well, the other point, I know we talked earlier about this, is you can do fast iterations. So you've got this cycle time advantage. If somebody on the team, a question comes in and you need something for a meeting on Monday morning, the question comes in Friday, you've got a shot at getting this turned around and ready for the meeting versus other approaches just can't possibly do that.
No, absolutely. The questions are endless. If you can come up with a question, you can build the model. If the data supports it is another issue, but you could on the fly have someone say, anything, an engagement question, a behavioral question, a donor, an attrition, all these kind of things, but on the fly. And I think the best approach for folks to have is to not necessarily build one model at a time. What I tried to do at Penn and what we've done here at MSU is we actually spent months building the basis for one model. So we pulled all our data and we had hundreds of fields, added hundreds of calculations. But to Doug's point, if someone asks us a question, we open the model, the data's fresh, and we can pretty much just by clicking on the attributes run a model within, what, a half an hour? And that's with a large data set. So it should not throw people off to want to give this a try.
Well, great. We need to finish up here. Let's give Dana Lisa a virtual thanks for taking the time to spend with us. Thanks a lot. Really appreciate it.
Thanks a lot, and I hope everyone enjoys the rest of the conference.
So we're back live, and we have some time for questions. If you have additional questions, feel free to either raise your hand or bring them in on the chat panel. There's a number of questions about data and how it gets loaded and how much it can handle. So Advisor is an in-memory based app, so we load tables from generally Oracle or SQL Server, can be Excel Access, different sources, and we put them in memory. And the two projects you saw in the webinar are multi-table, and they can load from multiple sources. We can run web-delivered or client-based. The analytics only runs in our client software. So one question specifically, is this the Advisor Analyst X product? Yes, it is. The client versions of our software, we can fit tens of millions of rows and like a 3 to 4 gigabyte footprint and run on a laptop or a PC. And it's typically we're loading in a production environment, I don't know, 50 Oracle tables, maybe 30 million rows. We generally update daily. We'll pull from the database, and then we're self-contained offline from the database with the data in memory. The analytics, the models you saw here, one had 20,000 items. The model's complete in like 15, 20 seconds. 100,000 items in the table might take 3 minutes, 2.5 minutes to complete, maybe a little less. We've done modeling with 1 million entities. That's we actually got a workshop going today. That's probably 20 minutes to complete on a reasonable laptop. So by modeling standards, the algorithms are quick and fast, and I'd say our range is typically up to a million-ish. You might push a few million entities in a table. I guess you could let the thing run a lot longer, but we're trying to do quick iteration, so that's typically our size range here. Once the data is loaded in a memory pool, we can roll tables up to collapse them, so we can parse tables apart. So if you got like 20 million things you're trying to model, you could, without changing the database, cut the table back to something smaller, do some models on it, and and adjust. How to handle nonlinear relationships is another question. So the algorithms here are, it's a multivariate regression where it's effectively is nonlinear. So if you look at a plot of data, like a scatter plot, it's trying to fit, it's linear within small ranges, but it's basically trying to fit a curve to that line based on the varying factors. And some of these tables have 150, 200 factors, as Dana Lisa was describing, and the model is going to look at all of them. So it's the model itself, age could be a factor. Then age, it's going to bin it into different groups. So age might actually have 6 subcategories to it. And then, address, if it's city, may bin the 6 cities into 30 different subgroups. So the model is at that level. So when it's, if you were to graph the model output, it pretty much is trying to fit a lot of small lines across a string of data. So it's a multivariate linear regression algorithm, but it basically fits curves. I think that is an answer to the question. Other questions, there's a whole bunch of them here. How much does it cost? That always comes up. So you can actually buy as a single user off our website. There's a section where you can, for loading Excel and Access and running with single tables, I think it's $999. So that's the in-memory part, the 15 visualization charts, and the predictive analytics. The projects we've been talking about here, like Dana Lisa, where we have an enterprise version of the product which is loading. The one on the website can't load 50 or 60 tables and do that. We have and generally there we're selling solutions because our team will help assemble the tables in a meaningful way so they link and join correctly and metrics are calculated properly. So there's sort of two ends to our business. But for an individual analyst, I just say the easiest thing, go to the website, and for under $1,000, you can get a single license and be up and running. What other? Yeah, there's a bunch of questions on what the algorithms are, R-squared coefficients, We will, as a follow-up to the webinar, when we send an announcement out about the video, we have some white papers on this which we'll point you to, so you can find the more technical definition of what exactly are the algorithms, what's the math behind them, how do you find an R-squared, all of that, rather than discuss that here in an issue of time. Other questions? Yeah, there's a group of questions about data prep. And so an answer to that is if there are obviously an SPSS or a SAS are very rich algorithms, and they require some statistics expertise, and they also require a bunch of data prep to use. The algorithms we use do, as Dana Lisa and we said, a lot of that behind the scenes. So whether it's this ordinal and there's string variables, there's different kinds of variables. There can be nulls in data. Before the regression model runs, it runs a data prep algorithm across all the fields. So it does a whole bunch of cleanup, and it deals well with all of that. It'll flag if there's something that it can't deal with or is unintelligible, but that's pretty rare. So all those binning, normalization, identifying what type of field each is, that is all automated. And the goal here is literally to have this point-and-click interface that you just have to select the things you want to look at. You can explore it visually, but then point and click and you get a model, and the output comes out in a form that you can understand what it's telling you. You can also click on the model outputs and look at the other charts in our project to see, like we did at the beginning, and visually explore the model output. But the goal is to take away all of that. How do I condition data? What algorithm do I pick? I need to run multiple models and find the best one. That's all automated under the covers, and when that was running, that's what's going on. So the goal there is, I think Dana Lisa is correct, and we're finding this across clients. People who don't have statistical backgrounds can use this because they understand the data, they know the question they want, and it's easy enough to get the software to run. And that being said, obviously, SPSS and SAS, and there are a bunch of very rich modeling tools out there, and our goal is not to compete in the statistics model with them. Our goal is to help business people and business analysts who need you can only go so far with visual discovery, because the projects we showed each have, I don't know, 80 or 100 fields pasted up across 10 or 15 pages. And you can visually explore it to a point, but back when we did the grades, it's really hard to tell how the high school relates to the professors. I mean, they're both, obviously there's a relationship there, but you can't cross-compare them really easily by just looking at it visually. And maybe there's some other stuff that you actually never saw on the charts. Well, the modeling is a more comprehensive run-through. It looks at everything, and then it cross-compares and sorts them out in a meaningful way. So that's sort of what we're trying to get at, is helping the business analyst, the business manager, put some mathematical rigor behind a visual discovery process so they can better understand what's in the data, and then use that model that gets created to score, to predict others or other groups or numbers. You can also forecast numbers in addition to the classification model that might have the same behavior, and from that you get this understanding. And that's a lot of what happens here. Is a lot of these examples, you want to rank lists of the top 100 to focus on for the end of the year campaign. It's Friday at noon, so the goal is to get that scored list. And we looked at the 1-0 bins. Well, that histogram showed a range score, so you can actually sort on the range score and get, not just the ones, but to get the top 100 out of the however many were binned into the one. You can get the list of the top 100. Boom, here it is. Go take action on them. Okay, how are we doing with other questions? Got a lot of questions here in front of me. I'm trying to sort them. A bunch of them are on the technical side about the algorithms, which I'm going to hold on. Any more coming in? I see we're writing. Hold on a second. Yeah, so there's a question about examples that illustrate time and cost savings in comparison between these in-memory based and traditional data analysis. I'll try to answer that in a minute. So the idea between this in-memory stuff is you pull data from a source system. It can be Oracle source tables. It can be a SQL Server data mart. It can be formatted stuff in Excel. It doesn't matter. You get it. And with the in-memory side, you had speed of thought interaction across tables. So when we did those selections earlier on, all that's happening in memory. I was running on a laptop that can run on a server with a web interface or a tablet interface. The concept's the same. It's data's in there at the base row and column, the detail level. The charts are aggregating it, and then when you're making selections, this whole mesh of tables is updating instantly, and everything updates on the fly, which is what that gives the end user is this ability to basically do ad hoc exploration across any combination of fields in that entire pool of data, which in the Michigan State example is their entire Oracle warehouse of alumni, friends, giving history, activities, student grades, all of that stuff's in the memory pool. It's like 60 tables, several tens of millions of rows is what Dana Lisa works with. The problem if you did it on a database, the query back, it's just the end users can't do the queries, and they're challenging queries because you've got one-to-many, many-to-one relationships across the tables. In a memory pool, you don't care because you're keeping them at the one-to-many, at the detail level, and you're just updating them on the fly through these selection links between the tables. So that's the in-memory enables that, and then that's what gives you this visual discovery capability. And then basically the analytics, what we've done is we've attached it to the data that's in the memory, much like a chart. So those algorithms are picking up from the tag data in the tables what's been selected, what's not. It's running, and then the output from the model, if you click on it, goes back and tags the data, so all the other charts in the project or dashboard update. And then when you score, it's connected to the entity table of, in some cases, 1,000,005, whatever, and just writing new columns back into the table in memory doesn't touch the database. So you have the results scored immediately. You can obviously then export them back to the database and do other things with them. But that's sort of the value of this in-memory capability. There's a report coming out on that from an analyst group in about a month, which if you're interested, and we're gonna make that available. And I think it's going to really help to better describe in-memory versus classic data marts and databases, and what this whole category is being called data discovery and analysis means to business people. It's a really well-written report with a lot of research behind it. It'll be out end of December. We'll post that, and we'll push it out when we get access to it. That is an area that's getting the Gartner Group, the Forrester Group, all the business intelligence industry analysts are doing more and more writing on this, because it is filling a gap in the market between, and this is what we're trying to position between reporting, which is more structured, formatted, production-based, and is high in analytics, which are too hard for most business people to use. We're intentionally trying to fill this gap, and it's the combination. Today you saw the predictive modeling, but it's linked in with putting the data in memory, and then the interactive visualizations all work together to give you this ability to do the kinds of things we talked about earlier in the webinar. That was a long answer to a question. There's more. Yeah, I'm seeing that. Okay, there's more questions coming in. I'm, though, realizing we're ran over a little bit here. We're going to give a minute for any last questions, and if we don't catch them on the webinar, we will be following up with you individually, because all the questions are being recorded and tracked, and we'll get this recording out to you guys within the week. We need some time to just process it. Any last questions? As I said, there's a whole bunch of technical questions here, which I'm going to defer on, and we'll send out material on that. Okay, well, I'm going to thank you all for attending. We had a large group on this webinar today, and thank again Dana Lisa, who spent the time to describe her work at both Michigan State and before that UPenn. So thanks, and have a good rest of the day. Take care.